Hey, what's up, guys? This is Chung here. So this time, LeetCode 1004, max consecutive ones, number 3. So you're given like a binary array numbers and an integer k. You need to return the maximum number of consecutive ones in the array if you can flip at most k zeros. Okay. So for example, we have this arrays here and k is equal to 2. So in this case, what the answer is 6 because so this is the longest consecutive ones we can get, which is 6, by flipping 2 zeros into 1, right? And so here's another example, right? And then the constraint is like 10 to the power of 9, and the k is the same as this one, right? So this one, I mean, since we're looking for like a consecutive ones, so this one, it's a sliding window problem, right? Basically, we just need to maintain like sliding window, and within that sliding window, we need to make sure the zeros in that sliding window will not be greater than k, right? That's how we can do it. Basically, we try to expand the sliding window as much as we can until the zero is exceeding k. Then that's when we stop. That's when we need to shrink the sliding window, right? Basically, sliding window is one way. The other one is like the binary search, right? So obviously the sliding window is O of n time complexity, but the binary search, even though it's n log n, but it's also worth mentioning here. Basically, so for the binary search, right, what we'll do is that we simply just directly search the answer, which is the maximum consecutive ones. Basically, we search that sliding window size directly, right? Because the reason being is because the longer the sliding window is, right, the longer the sliding window is, the the basically the zeros it includes will be uh, bigger, right? So which means that we keep increasing the sliding window size, keep going until it reaches a certain point, right? Once it reaches a certain point here, the zeros, right? Basically all the possible sliding windows with that specific size, the zeros will be greater than k, right? That's when we will need to stop, and that's how we use the basically the binary search to find the answer. Because with there, as you guys can see, we have a trending here, right? So the size of the sliding window, right, increasing, and then the k will also be increasing, right? So by the time this one is greater than this k here, that's when we need to stop. And yeah, so what shall we do here? Let's do the binary search first, because I think for sliding window it's kind of obvious, right? So I'd like to do a binary search. So for binary search, the obviously the left is 0, right, and the right is n, right? But we need to have an n first. That's the boundaries of this binary search. Okay, and then since we're looking for the maximum, right, and we can utilize the maximum sliding binary search template, right? L middle is going to be the L plus L minus the left divided by 2, right? And then we're going to have like helper functions, right? So basically these helper functions will take a size, basically fix a size of the sliding window, and then it will check with this size of sliding window, does it exist any window with this size whose zeros is either equal or smaller than k. If it is, then we know okay. So this size of sliding window is satisfy the condition, right? that's when we need to set the left equals to the middle, because we're looking for the maximum numbers. That's why, this basically this middle could be our answer. And since we're looking for the maximum, that's why we're trying to push the left boundaries as right to the right as possible, right? I think I have already talked about this maximum template a few times here, so I'm not going to too much of the detail here. Else, right? Else the middle. R is going to be the middle minus 1, right? So in the end, we return the L. Cool. So that's that. And then the only thing left is just to implement this helper function. So we're taking in the length of the sliding window, right? Or the size, or let's call it the length. And then we can do a flips, right? So equals to 0. So this flips actually is equals to the number of zeros, right? Within the sliding window. We have a bunch of ways we can do it. So for me, I just do this. We have the size of the length, right? And then flips equals to what? Basically, if the numbers of I, right, equal to 0, right, and then that's when we need to flip it, right? That's how we do a flips plus 1, right? And then basically, and then we check if the flips, right, it's either equal or smaller than k, and then we return true, right? So actually, you know what? So actually, this one can be simplified. Basically, no, we only increase by 1 when this one is 0, which means we can do what? We can do this, we can do this one kind of times I here. So this one means that what? Means the if we do XOR here, right? When this is 0, we have 1. When this is 1, we have 0. Actually, this one is equivalent to this one, You can either do a 1 minus this one, or you can do this one XOR this one. Basically, if it's 1, then we will not flip it, right? That's why we get 0. But if it's 0, then we need to flip it, right? Okay, and then we have I in range of length dot n, right? So this is where we start the moving the sliding window. So this is we create the first sliding window, and then we check that up, and then every time when we move to the current sliding window, we're gonna update the flips, right? So similarly as this one, right? So we need to increase the flips, right? And then we also gonna decrease the flips, right? For the left side, which is the I minus length, right? And then we do the same thing here, basically, right? So, and then in the end, right, return false, right? So you couldn't find any valid sliding window, right, or substring, right, or subarray. Then we return false in the end. Yep. So that's it. Run the code. I guess it should. Oh, yeah. So keep in mind that every time when you set this left to the middle, you need to do a plus 1 here. Otherwise, it will end up in an infinite loop here. Right. So now if I run it, okay, accept it, and then cool, right? So it passed. So as you guys can see, this one only beats like 5%, right? So the reason being is because this one is like n log n time complexity, right? Because we have, I think this one is n, right? The number is, yes, so this one is n, and this one is log n, and for each of the helper, we have a O of n, right? That's why we have this one. Yeah, so that's the sliding window. I'm sorry, not sliding window. That's the binary search, right? And then for the sliding window is pretty, actually, it's easier, you know. So same thing, right? We have n is going to be the length of numbers. So L is going to be 0, and then the answer is 0 as well. And then for R in range of n, right? So this time we can either use flips or we can use K. Yeah, let's stick with flips here, since I've been using flips from the beginning, right? Or you can decrease K. Either way is fine. So since we use flips for the binary search, let's stick with flips here. So basically flips gonna be plus, right? Same thing here for this one, right? Okay. And if the flips, right, is greater than K, right? That's when we need to shrink the left pointer, which is the so when we shrink it, we have to do this, right? Similarly as that binary search thing. So flips gonna be 1 XOR nums left, right? So this one is R, okay, and then we move L to it, move L to the right by 1, and then we can check if the flips, right, is either smaller than K. If it is, then we can update the answer, right? Dot L minus L plus 1, okay, and then return the answer in the end. Because here, you know, we need to check it again, because once this if is finished, right, it means that maybe the ones we are like moving out of the sliding window is 1, it's not 0. That's what, and if that's the case, you know, the flips will not be decreased, right? Which means that, you know, we have to keep shrinking the left until the flips is smaller than the K. That's when we can update the final answer, right? So run it. Yep. So that's it. Sliding window, right? And obviously this is a O of n time complexity. Yeah, I guess that's it, right? I mean, I don't know. Actually, you know, to me, I first came up with the binary search solution for some reason, and then while I'm implementing these helper functions, I realized that, you know, this one is actually a sliding window problem, where which means that we can simply just use a sliding window concept, right, with a left and right pointer to solve it. Yep, I think that's it, right? A very classic sliding window problem. And cool. Thank you for watching this video, guys, I guess, and then stay tuned. See you guys soon. Bye bye.